Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, determine the concentration of free electrons and holes in a sample of germanium at 300 Kelvin, which has a concentration of donor atoms equal to 2 times 10 to the power of 14 atoms per centimeter cube, and concentration of acceptor atoms equal to 3 times 10 to the power of 14 atoms per centimeter cube. Is this P or N type germanium? Okay. Now here they are asking whether it is P or N type. Now let's look at the given information. Here they are saying concentration of donor atom is equal to 2 times 10 to the power of 14 atoms per centimeter cube. So we know that Nd is equal to 2 times 10 to the power of 14 atoms per centimeter cube. Okay. And also we have the acceptor atoms, concentration of acceptor atoms equal to 3 times 10 to the power of 14 atoms per centimeter cube. So Na is equal to 3 times 10 to the power of 14 atoms per centimeter cube. Okay. Now we have the donor concentration and also acceptor concentration. From this one we can find out whether it is P type or N type semiconductor by comparing this concentration. Here you can directly see this Na concentration is higher than donor concentration. So we know that this is a P type. So whenever we have acceptor concentration is higher than donor concentration, that is P type. If the donor concentration is higher, that's going to be N type. So this is P type semiconductor. Now we have to find out the new hole concentration. Initially we had holes concentration, that is 3 times, because acceptor is holes, 3 times 10 to the power of 14, and donor's concentration 2 times 10 to the power of 14. Now to find out the new holes concentration, because they are asking for the free electron and hole, determine the concentration of free electron and holes, and determining P or N type, one of the question we did that one. We had to do these two parts. Okay. Now to find the new hole concentration, we just have to subtract hole from actually electron from holes, because donors are electron, acceptors are holes. So because we know that acceptors are higher than holes, so Na minus Nd, that's going to give us a new holes concentration. That's going to be 1 times 10 to the power of 14, because we have 3 times 10 to the power of 14 minus 2 times 10 to the power of 14. That's going to give us 1 times 10 to the power of 14 atoms per centimeter cube. Okay, so this is nothing but P, that's holes concentration. Now we have to find out majority is holes, minority is free electrons. Now to find out the minority concentration, we just have to use mass-action law. That's given by N is equal to Ni square divided by Na. Na is nothing but intrinsic concentration of germanium, and here they have mentioned germanium at 300 Kelvin. So that one is 2.5 times 10 to the power of 13. So this is the intrinsic intrinsic concentration of germanium at 300 Kelvin, and that one square divided by Na, actually Na prime, that's the new hole concentration. That's given by 1 times, we found that one, that's 1 times 10 to the power of 14, and if you divide you will get 6.25 times 10 to the power of 26, and this is 2.5 square, that's 6.25, and we have 10 to the power of 26 when we square 10 to the power of 13, and also we have 10 to the power of 14 in the denominator, and finally we will get the number of free electron concentration. That's going to be equal to 6.25 times 10 to the power of 12 electrons per centimeter cube, and that's going to be the final answer. I hope this helps. Thanks for watching.